It's here, and here, and here too. You may not know it, but chances are, every day, in some way, powder metallurgy touches your life. It's there as you go about your daily routines. You'll find it hard at work, wherever people are on the job. Helping grow the food we eat. Transporting the necessities of life on the road, on the ocean, or in the air. Helping bring essential power to our homes and to our cars. Transporting us to and from our workplaces. Or carrying us about at our leisure, making possible more abundant health at every age. And easing the work of those who bring wellness to us. Bringing people together through high-tech communications, or through creative expression, helping enrich hours of carefree recreation. Or enhancing serious athletic competition. Whether helping maintain the surroundings of our homes, or the defense of the country. Whether helping advance particle physics deep below ground, or playing a role in the search for oil beneath the sea. Powder metallurgy is there, the preferred metal forming solution. PM is a proven state-of-the-art technology for producing net-shaped metal components of every imaginable design configuration, in sizes ranging from tiny to huge, from any one of a dazzling array of material systems, both ferrous and non-ferrous. Powder metallurgy offers component designers and product manufacturers a long list of advantages when compared to other metal forming processes. It makes possible complex or unique shapes that would otherwise be impractical or even impossible. Eliminates or minimizes machining as well as scrap. Provides a high material yield ratio. Improves quality rates through excellent part-to-part repeatability. Offers long-term performance reliability in critical applications, and it's cost-effective in moderate to high-volume production applications. PM's obvious benefits: decreased energy consumption through fewer manufacturing steps, reduced waste through improved material utilization and scrap reclamation, longer product life through increased component reliability, cost competitiveness that encourages domestic part production. These all contribute to sustainable manufacturing, making powder metallurgy the preferred metal forming solution for the 21st century. It's somewhat inaccurate to refer to PM as a part-forming technology. In reality, it is a constellation of technologies, each distinct and unique, all having in common the fact that they start out with metal in powder form and through the application of pressure and heat end up with finished components. Conventional powder metallurgy, commonly referred to as press and sinter PM, produces finished parts by shaping metal powder within custom dies under tremendous pressure on sophisticated compacting presses, yielding what are called green compacts, which hold their shape through a mechanical bond of the particles sufficiently strong to allow them to be handled. Then heating the parts in furnaces with highly controlled atmospheres to a temperature below the metal's melting point, a process known as sintering, to impart the component's metallurgical properties. Powder injection molding produces highly complex shapes in relatively small parts, generally under 250 grams, using conventional injection molding machines. A custom feedstock made of fine metal powder and a binder is granulated, heated, and fed into multiple cavities of a molding machine. The emerging green parts then undergo thermal or solvent processing to remove most of the binder material. The remaining traces of binder are removed as the parts pass through the sintering furnace and shrink to their final dimensions, achieving relative densities generally greater than 96%. When it comes to fabricating extremely large parts with complex shapes from metal powder, there's a technology called hot isostatic pressing, generally known by its acronym of HIP. The powder is enclosed within a custom hermetic container shaped like the part being formed. Then, inside a special high-pressure vessel at an elevated temperature, high-pressure gas is used to apply force simultaneously from every direction to deform the container and compact and sinter the powder within it to 100% of its theoretical density. And there are still other techniques that are embraced within the definition of powder metallurgy. There's cold isostatic pressing performed at room temperature and using a shaped elastomeric mold to contain the powder, which is uniformly pressed in all directions by a liquid pressurizing medium. There's what's called roll compacting, which produces a continuous strip or sheet from which many kinds of thin, flat, final products are fabricated. There's spray forming, which deposits metal particles onto a substrate, producing semi-finished mill products in the form of billets, tubes, and sheet or plate. Whichever PM technique is ultimately most suitable for the requirements of your part, you'll benefit from all the advantages PM offers: enhanced material yield ratio, energy conservation, increased design flexibility, long-term performance reliability, and cost-effectiveness. Advantages that have made PM the sustainable manufacturing technology it has always been. Let's get to know it a little better.